In this script, I will talk about boundary conditions for perfect dielectric materials. Let's consider the interface between two dielectrics. Having permittivities epsilon 1 and epsilon 2 as shown here, we are interested in conditions at the interface. The condition for E and D. There are two components. E sub t is a tangential component and E sub n is a normal component for electric field. Let's call the surface right at the interface in the region 1 surface S plus and the surface right at the interface in the region 2 S minus. We have two regions shown here. We'll use these two equations. The integral E.dl on a closed loop is 0, which we learned in the topic of potential, and the Gauss law integrate D.ds on a closed surface is the charge enclosed by the surface. The first one is to show the conditions of tangential component, and the second one is to show the conditions for the normal component. For the first equation, we construct a small loop on the interface. As shown here, we compute the integral on the small loop by letting delta H approach 0. The path is only on S plus and S minus. We have the integral as shown here. The path on S plus is the same direction as electric field. Then the dot product is a positive value. But on the S minus, the path is in an opposite direction. Then the result is a negative value. The length delta W of the path is small, but it's not 0. We can conclude that ET1 subtract with ET2 is 0, or ET1 equals to ET2, or the tangential component of the electric field must be continuous across the interface. The second equation, we construct a small volume on the interface as shown here. By letting delta H approach 0, the surface delta S1 is right on the surface S plus, with the direction of pointing outward from the volume as shown here, and delta S2 is right at the surface S minus. The direction is shown here. We compute the integral on a small closed surface. By letting delta H approach 0, the volume also approaches 0. Then the volume integral is 0 or no charge in the volume, except if we have a surface charge which has infinity coulomb per cubic meter. Then the enclosed charge is the surface charge, or the surface charge density rho sub h times delta S. We then compute the electric flux passing through the closed surface. Since delta H approaches 0, the only flux passing through delta S1 and delta S2 is left. We replace D with permittivity times E. Then we have this equation. Since delta S1 and En1 is in the same direction, the dot product is a positive value, and delta S2 and En2 is in opposite direction. The dot product is a negative value. The surface integral equals to the enclosed charge. We cancel out the delta S and obtain these conditions for the normal component. Both conditions for tangential and normal components are shown here. Now, let's consider the interface between a dielectric and a conductor as shown here. The region 2 is a conductor with a conductivity of sigma. Electric field in region 2 is 0. This leads to a conditions on conducting surface. The tangential component of electric field is vanished, and the normal component is the charge density on the surface.